For centuries, intelligence was a biological privilege, a miracle of flesh, bone, and blood, but now, a new species is awakening. An intelligence born of silicon, electricity, and pure mathematics. Today, we are witnessing the greatest engineering revolution in history. We are coding the essence of thought and rebuilding it, but this time, not from flesh and bone, but from silicon and electricity. When you talk to an AI model, you aren't just chatting with software. You are talking to an ocean where billions of parameters turn into electrical signals flowing at the speed of light through massive data centers. So how can a pile of lifeless metal write a story or a poem? Or a more chilling question, can a machine truly understand? To find the answer, we must go beyond the interface. It's time to open the black box. This is Axiom Tech. Let's begin. In the world of artificial intelligence, there are no words. There are only numbers, but not ordinary numbers. They are coordinates. To understand this, let's go back to high school math, the coordinate plane. On a two-dimensional sheet of paper, every point has a position, right? Now imagine this paper has 10,000 dimensions. As engineers, we transform every word in a language into a vector within this multidimensional space. In this space, words with similar meanings physically stand next to each other. For example, if you mathematically subtract the concept of man from the word king and add the concept of woman, the system automatically leads you to the coordinates of queen. This is not magic. This is the mathematics of language. The machine doesn't know what a queen is. It simply calculates that her distance from king is the same as the distance between woman and man. For artificial intelligence, meaning is the distance between words. We call this the latent space. However, just mapping words isn't enough. To understand a sentence, you need context. Until 2017, machines were dumb in this regard. That is, until the 19 transformer architecture and its heart, the attention mechanism, were invented. The attention mechanism is the system determining where a machine should focus while reading a sentence. Consider the sentence, I went to the bank and closed my account. Here, the word bank is a financial institution, but if I said I sat on the bank of the river, the meaning would change completely. The transformer architecture calculates the relationship of every word in the sentence with every other word simultaneously. Billions of matrix multiplications happen in a thousandth of a second. The machine assigns a weight score to how much one word affects the other. This is the most complex traffic control system in engineering history. We frequently hear that GPT-4, Gemini 3, Kimi K2.5, and DeepSeek V3.2 have trillions of parameters. But what physically is a parameter? We call the strength of the connection between two neurons in a neural network a parameter. Just like synapses in the human brain, to train a model means to turn these trillions of tiny knobs to the exact right position. Initially, the model talks nonsense, but as it reads terabytes of data, an error correction algorithm called backpropagation kicks in. With every mistake, the system goes back and very slightly tightens or loosens billions of knobs. It repeats this quadrillions of times. Finally, from that chaotic noise, a symphony, that is intelligence, is born. This digital mind doesn't live in the clouds. It lives in cold, noisy, and massive energy-consuming physical fortresses. The AI revolution is as much a triumph of hardware as it is of software. NVIDIA's H100 chips, Google's TPU pods. These are the pyramids of the modern age. Training a single large model can consume the electricity a small city uses in a year. We engineers are no longer just optimizing code. We are optimizing heat, electricity, and the physical limits of silicon. We have reached the limits of Moore's law, and now we are designing FPGAs, ASICs, and custom chips to break it. Artificial intelligence is not magic. It is a product of mathematics, statistics, and high-performance engineering. We started imitating human intelligence, but perhaps what we created will be a completely different, a much more alien type of intelligence. Engineering history began with the wheel, accelerated with steam, and now thinks with silicon. We are not just spectators, we are architects, and this structure has just begun to rise. Stay tuned to decode the deep architecture of technology with us. This is Axiom Tech, and I am Epoch.